Hi, welcome to this Open Security Summit session in January 2024. And we have Dwayne that is going to talk to us about a lot of the stuff you can do with Git hooks, which is one of those superpowers that not everybody's fully aware of what you can do. And starting with stop committing your secrets, but I'm sure going to expand to a lot of other things you can do with it. Over to you, Dwayne.
Oh, sure. Thanks very much for having me, Dennis. And greetings to everybody out there watching either today or in the future, the Open Security Summit. A lot of great content in this event, so hopefully you're getting a lot out of it. So yeah, as I was introduced, I'm Dwayne. I live in Chicago, Illinois. I've been a developer advocate, talking in public about various things since about 2016. Um, you can find me out on the internet a bunch of places like MC Dwayne, Mastodon. I try to be there more than I'm on Twitter, but I'm on LinkedIn more than I'm anywhere else, and that's my just full name. I co-host the Security Repo podcast. So if you hear something I mentioned about security today, or like I'd like to drill into that a little bit further, there's a good chance we've already dug into that on the Repo podcast. We have all sorts of amazing guests on there: Tanya Jonka, Jason Haddix, security experts from like people that break into banks to people that defend software on the daily. Um, also, outside of tech, I'm a person just like you. I love going to improv shows, karaoke. I love rock and roll. So that's me. If you ever want to hit me up about that stuff, feel free. But I'm here really to talk about Git hooks. But I also did want to mention where I work. Very briefly, the people that pay me to work day to day is Git Guardian. They'll come up a little bit later in the talk, so I won't spend too much time right this second. But they are a platform dedicated to finding hard-coded credentials and helping you solve that problem. The coordination and the remediation side of things, as well as IAC. In the future, we're coming out with some other really cool stuff. We have honey tokens now, but that's a whole other talk. All right, enough about that. So why we're here? Why am I talking about this? Because we live in this world. I reuse this slide in pretty much all my talks these days because it's never not true. We are over there on the right as Scratchy trying to defend all of our data from these people out there with chainsaws and tools they don't really understand. All they know is, for the most part, they're following these scripts. There are multiple types of attackers. There are the people doing it for the lulz, just the hacktivists that I want to make you guys look bad, so I'm going to break in and do something, make you look dumb. There's advanced threat actors, nation state actors, Lapsus Group, or I'm sorry, Lazarus Group out of North Korea, the Chinese state actors. Good luck defending on those. They're going to figure out a way in over decades. But the vast majority, according to Verizon's DBIR, which is a great report that comes out every year, Sophos report, CISA, the vast majority of attacks come from cybercrime. And they are there to get in and get your stuff. Specifically, they want your data and they want your machine resources. Data is pretty obvious why they want that. Because, well, they can sell it, they can ransom it, they can do a lot of things with your data. Data is the lifeblood of your org, and they know that. They also want your machine resources. There was just a report, I think yesterday, someone made $1 million by spending up over 1 million virtual machines once they had access to a system and crypto mined until they made about $1 million US. Maybe it happened last week, but anyway, I read the report yesterday. I want to say a few more scary things like that. It's not a hopeless situation, and that's what the whole rest of the talk's about. But I'm going to say a couple of horror stories of like, so what can go wrong? Like, what is the specific problem I'm talking about in defense and how we're letting them in? And if you get a little scared, just recite the Bene Gesserit litany against fear, and you will be fine. But so what can go wrong, and how can attackers gain a foothold and then end up pwning us? Well, Uber experienced this back in 2022. I'm gonna have to get a few more new examples. I'm realizing we're here in 2024, and this feels like forever ago, but this is still a very valid story. A super admin at Uber got phished. They had multi-factor authentication turned on. It wasn't that they were doing it wrong, but they got flooded by so many requests so fast that the guess is their thumb slipped or they eventually just gave in. Eventually, it just wears you down. I don't know if you've ever been in that situation, but it's exhausting. just to have a million alerts on your phone. Anyway, once the user was in, they look around. They did the land and expand, living off the land strategy, realize, hey, there are PowerShell scripts in here that are chock full of credentials, hard-coded secrets that will get me into their PAM. And then that's everything. They taunted HackerOne from inside HackerOne's interface. They flooded the Slack channels full of memes, and nobody believed them. They thought it was a joke. They thought it was an eternal prankster. Next person that this attacker talked to was the New York Times, and that's why we know the story. Maybe you lived through this, maybe you didn't. A little over a year ago, Circle CI experienced a massive interruption in service. Probably at least one person listening to this at some point in time will have been affected by this. January 3rd or 2nd, 2023, everyone wakes up and gets an email saying, hey, we had to rotate your authentication tokens because we had an attacker get in through a developer's system. This is a remote developer who was running an unpatched Plex server on their work machine for some reason. That Plex server gave that initial attacker access because they never patched anything, and they never reset according to the stories I've heard, never reset the admin default password. So get in through that password. Once they're inside, they realize, hey, this is Circle CI internal. Let's start stealing all the tokens. Let's steal all the passwords. They use those tokens to get into customers' accounts and start stealing their passwords. The same day they announced this, there was a report on Twitter. A security researcher said, hey, all of my honey tokens, my decoy credentials inside of Circle CI have gone off. Somebody's in there doing something. And that was the day they announced, hey, we've rotated these. And well, that's the only thing they could do. Maybe a little less complex. Toyota, maybe you got hit by this. Maybe you don't know about this. If you drive a Toyota, you should know about this. The T-Connect repo, T-Connect is their remote car start system they have. It does a lot of other things. It's a really cool system. I'm actually a big fan of Toyota. They had a subcontractor who got access to the private repo and then pushed, for some reason, part of that T-Connect repo into a public GitHub repo under a different name. It contained a real data server key, though, and the address for it. So anybody that found that open source repo could then get into that customer data server, and that's how over 296,000 customers were exposed for over 5 years. It took them 5 years to figure that out. AstraZeneca, I'll speed up a little bit because this is getting a little monotonous, but developer one accidentally pushes test environment credentials out into public GitHub repo. Developer two accidentally pushes patient data into that test environment. This situation persists for about a year, as far as what AstraZeneca disclosed in November 2022. That's a long time for very sensitive customer data to be exposed to pretty much anybody that has a GitHub account or has access to GitHub Public, which is literally the entire internet. This is basically the problem that we exist as a company at GitGuardian to fix, and it's the problem that unfortunately keeps getting worse. And this is dumb, obviously. This is about the extent of my Photoshop skills, so it's only going to get crazier from here. But we're leaving the key out front. We built these great big walls. We fine-tune our WAFs and our other systems so well, but then we just leave the key out. We do things like this because it's a matter of expediency. Now, this is kind of a dumb thing as well, but this is real. I'm guessing whatever's on the other side of that door isn't mission critical for this company. It might be staplers, it might be copier paper, it might be somewhat important, but not mission critical stuff. And that's a really complex lock. So to get around the complex lock and the overly complex system, oh, I'm just going to post this up there, it'll be fine. Maybe it was. I don't know. But I do know we do this all the time. If you ever try to debug something as a developer, eventually you just hard code the credential in there, because I just got to make sure that key works. I got to make sure that database is up. I got to make sure that API endpoint actually responds. And we're doing this in the middle of debugging, and we're doing this in the middle of testing. And our thought process isn't how do I revert all of this so I'm 100% safe and don't leak things. It's I just got to get this working. I got to close the ticket and I got to go home. And it's not you're working in one file. If you ever debug something, you're opening like 20 to 100 files, going through hundreds of lines of code, trying to pin down where exactly did things go wrong. And then it hits the end of the day. And what do? You save, add, commit, push, go home. So we're not really blaming anybody as being malicious. Yes, insider threats exist. Yes, people do things maliciously sometimes. We think that is the very small part of this problem that I'm showing right now. You can go to getguardian.com/state of secret sprawl report 2023, or just Google that. That's the fastest way to get there, honestly. Last year, in 2022, we scanned over 1 billion commits. We scanned every single commit that got added to GitHub publicly. We found 10 million secrets there. That's a lot of secrets. That's 1 out of every 100 commits that got onto GitHub. That's 1 out of every 10 committers on GitHub is what they averaged out to. 5.5 commits out of every 1,000 exposed a secret. This is an increase. This is a 67% increase of the year before. And the year before that, it was more than double. So it's like 2 million, 6 million, 10 million. This year, I know that number's higher, but I'm not allowed to release it just yet. We're releasing that later this year for the 2023 numbers. So who's responsible? Well, turns out it's everybody. It's not just that developer who's working on debugging something. It's people in a hurry. It's people that are laying their passwords out into places like outside of code, like in configuration files, into env files that don't get properly stored. Basically, anybody that touches these secrets has the chance to leak them. Don't really talk about it in here. It doesn't really address it in this talk, but they also get leaked in places like Jira and Slack and Discord more and more. Security teams can't tackle this on their own. Like, this is something so big, it's so overwhelming of a problem that unless we get a handle on it at the developer level, at the extreme left, and the software development life cycle, that's what shifting left is really all about. Let's move security further and further to the left earlier in the process so it's cheaper, easier, and scalable to fix. That's what we're really doing here. Now, I'm not saying, hey, every developer, you need to go throw on a security hat and you need to learn all these security tools. You need to rethink your paradigm. You need to become a security expert. If you want to, I would love for you to do that. There's a lot of awesome benefits to being a security expert on top of being a developer. But really what I'm talking about here is let's leverage the tool you already have to do something to make everyone's life a little better, including yours. Because nobody likes getting yelled at by security, especially if something goes all the way to production. Living in these really highly connected world of DevOps, when a secret does get leaked and you realize it's in production, you can't just rip it out right now. I mean, you might be able to. If you're the only developer working on a project, you know all of the dependencies and you know everything that will cascade fail if you stop a system from being there for even a few minutes, then yeah, go ahead, rip and replace. You know what you're doing. For everyone else, like, you have to stop and think, like, what will fail if I remove the secret? If this system's no longer available to connect to that system, how much money will we lose overall? It might be none. It might cost you your business. I don't know. That answer is going to depend completely on the situation. So let's stop that from even being a conversation and say, hey, I stopped it before it got committed, and everybody's happy now. The tool we're going to use to do this is one you already know and love if you are 97.8% of the development population on Earth, and that is Git. That was the last number I saw of adoption for Git. So there might be something to replace it in a few years. I like having that conversation in the hallways at conferences, like, hey, what's going to replace Git? Maybe something, maybe nothing. Maybe this will be the new one standard we all stick to for the rest of time. But Git's awesome. It doesn't make your code any more or less secure on its own, though. If you type man git into a terminal, it still to this day tells you it's the stupid content tracker. That's how Linus Torvald thought of it. That is how Gitster still thinks of it. It's a content tracker. It tracks things over time. it's not a security tool. So why am I talking about it in the scope of security? I'll get back to that. Surprise, I'm giving a second talk inside of this talk just to get us all up to speed and make sure we're all on the same page, because there might be security people here that don't quite understand Git from a fundamental perspective. And it's really important to, in my opinion, when you're dealing with code security. So very quickly, I'm not going to go into the whole history, but 2005, Linus Torvald sends an email into the Linux Linux mailing list that says, hey, here's a bunch of patches I'm using to manage, or here's a bunch of scripts I'm using to manage patches. I don't think it's ever going to become a full source control management system. 3 months later, they name it Git. Gitster is put in charge of it. Junio lives in Japan. I think he lives in Japan these days. Anyway, Junio is put in charge of it. And for almost 20 or almost 30 years now, or no, 20 years now, we have had, Git's not even 20 years old yet. We have had this as the main way we think about tracking things, tracking code, tracking changes. But really, what he was doing with his scripts was saying, I need to track the file system itself to be able to track what changed inside that file system. And that's a really important thing to think about. At least I think so when you're thinking of securing all this stuff. But Git really does 3 things at a fundamental level. What happened in a directory? When did those things happen? Causes them to happen. If you're going to build it from scratch today using tools off the shelf that you could easily download, you might use 7-zip. They use zlib internally, which is or zpack internally, which is a super compressed way to do things. It's very efficient. Works for text files. That's what it's built for. But you might use 7-zip, but you need a compression algorithm. You need a universal time tracking system, which we have. It's called Unix time. We are 1.6 billion seconds into it right now. It started January 1st, 1970. We're in the Epic one. We're in the Epic right now, but it's there. Every computer on Earth knows what time it is based on that plus or minus UTC. And that's how Git still does it. And you need a way to write things down and store them over time. Since Linus was building Linux and he was using built-in GNU tools, hey, text lists work great for this. Text files are universal. They just work, assuming your UTC or your encoding is correct, but it just works. And that is literally what they built. That's what Git does. That it's not anything more complicated than that on its base level. It does have this weird concept of controlling reality, though. Unlike anything else in the entirety of computer science that I know about, it deals with multiple realities and time travel, which is weird. The way I think about that is this picture here and there. This is in Oakland and Berkeley, California. That you're looking at the border between these 2 cities. Gertrude Stein once famously said off the cuff, the problem with Oakland is there's no there. So artists in the 70s built a there in Oakland, and they built a here in Berkeley. So you could look over there from here. Depending on where you are, here is over there. And you could be standing in front of there, and then here would be there to you, but here would be over there at the same time. Don't overthink that, but it's kind of a fun paradox to start thinking in terms of like, what do you mean by here? And what do you mean by there? What do you mean by this? What do you mean by this reality? Well, Git has a way to track that, and it's very convenient. And it's very efficient. It's called head. It's right there. It's 20 bytes big in this particular instance. I actually have a real repo up here, and I see this is head right there. So if I run a in here, yeah, 23 bytes big currently in this repo that I got open. That's all it is. So what's in head? Well, it's simply a reference to where reality is at any given time. So when you say you're checking out something or you're switching between things in Git, this is what's changing. Head's pointing to somewhere else. So what is this pointing to? I'm skipping a few steps here because we're not, and this isn't a Git class, but eventually you end up with this thing called packed refs. And packed is the full list of all of the references with the fully qualified ID for that commit. References to those snapshots in time. Every time you go to make a commit, Git builds a new snapshot, and those commits stack on top of each other over time. Git's also really, really smart. At the same time, it's stupid because it knows if something changed. So if you make changes to file A, well, now you have a brand new version of reality where A is A1, but B keeps being B. So instead of making a new copy of this, it'll just point back in time and say, okay, all right, well, this is B, just go reference it back from, or like something else in history. What's inside these commits? This is where I think Git gets really, really cool, and I could spend a whole hour just talking about this slide. But I'm not going to. Basically, you can press down text files into very, 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 very small things called blobs. Blobs are binary large objects, or binary log objects, depending on when you ask the question. And what a binary large is what pretty much everybody considers now. You pack these references into a tree. That tree is your index. So there's a file over here. Open anyway. Yep, this open. Get out of the way. Okay, so this is what my index for this actually looks like. See how it's mostly like, I can't read that. It's binary weirdness. But hey, there's actually also file names in here. That's what you're storing. You're storing the name of the thing as part of the blob that is the thing. And then when you make a commit, you're saying, all right, make a permanent record of this tree at this point in time. Side note, you can control this down to the blob level inside of every commit. You can go edit individual lines of a blob in any commit you've ever made. You have full control over your history. Git is super powerful in that respect. All right. So anyway, it takes these commits and stacks them together, and you get, well, you get your history. You get history. So if I run over here and do a git history, or git log is what the command is, I get this beautiful, really long, well, this case is really short, list of everything I've done. You can format that in different ways to look at it. So why am I saying all this? This is a security talk, right? Yes. If you make a commit with a hard-coded plain text credential for, say, a database server, or the secret, the API key for your AWS master account, it's going to be here. And then when you commit to the next commit, you take it back out. Guess what? It's still here. It's there forever unless you surgically remove it. That's the problem. It's not just that people are committing secrets on the top level and pushing them out to GitHub. They're taking them back out in the next commit and thinking no one's going to look there. And they're there literally forever. Because it's not just tracking diffs. It uses diffs to move changes around and inform various servers. This is what changed in an efficient way, but it's actually tracking that full file system, including all of those previous commits. That's my whole point there. All right, back to what you originally signed up for, Git hooks to the rescue. Now, Git does give us a way to exclude things and a safety check. So if you're working in a file and like, I have an env file and I am going to put all of my credentials in there, and then I'll simply exclude it. I will tell Git to ignore it and everything's fine, right? If we were in person, I'd ask you to like shout it out, but there's an obvious problem right here. And that's we've commented out by accident env. I know this is by accident because I did this. This is a real example from my actual real world use case. I realized, why is env getting my repo? Oh, because I accidentally commented that out somehow. Still not sure how I did it to this day, but that's the point. It's easy to mess around with it. Now it's really powerful. You can Git ignore, and it's a nice additional safety layer if you're doing things like AWS suggests. So AWS by default wants you to store your .aws folder in your home directory, at least on Mac and Linux, in a home directory / credential or secrets or config. No, it's creds slash credential, but that's away from your working directory. So Git's never going to track that anyway. But if you have that git ignore on top of storing it outside, it's a double check. It's nice. And then there are so many other way better ways to store your secrets. This isn't a talk about these items, but if you've never looked into a vault system, this should be on your list of what to do basically next. Key vaults, I just mentioned two here. So HashiCorp vaults, or Vault by HashiCorp. It used to be open source. It's still BSL, business licensed. It's still free to use, is my point. Azure Key Vault is built into Azure. AWS has Secret Manager. Google has Credential Manager, or I think maybe they call it Secret Manager. I forget. But anyway, vault systems are great for a number of reasons. One, they very securely store your keys, and then you programmatically call into the vault to get them. Now, there's a little bit of complexity around how do I authenticate to that vault, but it's not really kicking the can down the road. There are certificates and certificate management systems that handle that exceptionally well, built into these tools. Anyway, they also have some accountability. You can see when a secret got added in. You can see when a secret got rotated. You can even see when a secret was accessed. Auditability is a very important thing, and it's going to become more important as we move forward. So again, not to talk about these things, but if you haven't looked into these yet, put them on your list. Go talk to your developers about them. They're a really good idea. So if we have git ignore, so we can ignore any of our env files or where we're storing those secrets outside of code, and we have paths like this where we can very securely and properly store our credentials for production use or for dev, or even for local dev, you can use these tools. Then we shouldn't have a problem, right? Well, in a perfect world, we would 100% adopt those best practices and we would move on, and I would never give this talk again. But I've been giving this talk since 2021. No joke. This is you're seeing the most current version, but still, I still have to keep repeating this out in public. We keep doing this. The numbers show we're getting worse at it, not better. And I'm not here to shame anybody. You got to get your job done. Your job as a developer is to close those tickets and to get production code out into production. And testing it locally. We all do it. I'm not shaming anyone to do that. The issue is we get lazy sometimes in a bad way. There's lazy in a good way and lazy in a bad way. I'll come back to that later. But we get lazy in a bad way and like, oh, I'll just put it in there temporarily. And then we forget to pull it back out. And then we commit it and push it. And you're just going to have a bad time for a number of reasons. Because in theory, you can rewrite your Git history altogether from scratch down to the blob level, like I showed. And that's easy to do locally before you share that repo. If you have a repo you just spin up on your machine, you have complete control of it. There's nothing you can't do. Rebase is your friend. It's awesome. It's complicated, but it's awesome. But once you've pushed that repo, it's basically not impossible, but improbable you'll ever get that secret back out. Get everybody to agree on that version of reality, at least. Because once someone else has cloned down that repo, well, now they have a full history of the entire project, including all of those secrets. So you need to convince individual people to change their repos and all agree to force push and pull at the same exact time. And if one person doesn't, you get the idea. I'll stop over beating the head on that one. But it's also painful from a just work perspective. Going to your fellow employees and being like, yep, I messed up, and now we have to rotate a secret in production that might cause downtime, might cost us millions of dollars. Sorry, that's not a good day. And I don't want anybody to be there. What we need is a robot. Robots are awesome. Not botnets that are destroying the internet. That's a whole other different talk. But robots in concept are awesome because robots are really good at doing repetitive things the same way every time, forever. And the good news is there's a built-in way in Git to build robots. This is where laziness is a good idea. Hey, I do this manually all the time. Can I just automate this? And the answer is if you can script it, if you can do it line by line in a command line interface inside of a terminal, then absolutely you can automate it. You can do a thing, Git triggers a thing. That is, or you want to do a thing, you do a thing in Git triggers that thing to happen. That's basically what's happened. You can build your own really complex Rube Goldberg devices if you want. Sky's the limit. There are 17 Git hooks. If you go to no other website based on this, like even if you don't go to Git Guardian's website, that's fine with me. As long as you go to githooks.com, write that down, open that in another tab right now if you're watching online, and bookmark it. It is such a great resource. Thank you, Matthew Hudson, for building this. It is a little bit dated, but that's fine because Git hooks haven't updated in a long time because, well, that's core Git. The 3 hooks that we care about are pre-commit, prepare message commit, and commit message. These 3 are triggered by the commit process itself, but all 3 of them happen before the commit is finished. If anything goes wrong inside of one of those scripts, the commit just stops and doesn't get completed. Now you can do anything you want inside of these. The only rule is you have to name it exactly the name of the hook. So for instance, this is called pre-commit.sample. If I wanted to activate this and make Git start picking it up, I would just remove the .sample. So I would have a hook simply called pre-commit. And that would run every single time I went to go make a commit. Now, if you go look inside of a Git folder right now, here we are, inside of a Git folder. Here's my hook folder. I don't need you anymore. I have this whole crazy list of .sample files. I also have a post commit and a pre commit in there. We'll come back to those later. But if you look in the examples, you're going to see things that look like this. This is what Linus was using. This is what the Linux project agreed. This is how we should do this. So that's why these exist. Do you need to know what rev parse and hash object do? No, those are plumbing commands. They're really deep in there. Rev parse is awesome. If you just look up the command itself, it's pick out and massage parameters. It's one of the very few places in computer science where you use the word massage. I just kind of like that. Like the actual description of git hash object is compute object ID and optionally create a blob from a file. Again, you can control down to the blob level, but again, you're probably not going to use that in your day-to-day life. What you can do in your day-to-day life is anything else that's going to be helpful. I personally like to have dumb jokes throughout my log files, so I will add in I can ask dad joke, which is a site you can curl and it will spit back a dad joke, for instance here. So when I made this commit, I got this joke back. I'm doing this in Bash because I personally like Bash. You can do it in anything you got access to. So if you love scripting in Perl, go for it. More likely you'll use JavaScript or Python or PHP, whatever you're really like. R, Rust, I could update this now. But if it will run locally and you have access to it, your CLI, your terminal has access to it, it's up to you. All right, so we have this automation platform. We know how to build robots now. Let's go back and look at the use case we just talked about. And if we were going to build a solution to say this, to stop me from hard coding secrets, so I'm not opening the door and letting strangers into my environments, it would look something like this. Before I make the commit, go check and see if I hard coded any of those secrets, those username, passwords, API keys, what have you. And if I did, throw an error and stop the commit. Maybe spit out some other text, but right now, let's stay with us. You could build this yourself. In fact, if this is a brand new concept to you, if Git hooks are a brand new concept to you, I'd recommend start playing around with like something like this on the left. If you have time, if this is something you can go explore and you think it looks neat. Here I'm using Git grep. One of the cool things about Git that I really love is that Git was built on top of what he was doing with Linux. So he just incorporated a bunch of bash tools into Git because it saved him time. He being Linus Torvald and the team that originally was building Linux. So this is fun. A Git grep runs a grep. I'm running specifically regular expression grep right here, but it only looks at the index. It doesn't care about the rest of your machine. So it narrows down that problem of where is grep looking. Anyway, so here I'm just looking for anything that looks like password or password equals. I'm looking for this particular regular expression, which is 20 characters long, containing all caps and 0 through 9, which is an AWS key. I could specifically say it starts with AKI if I was specifically looking for an AWS key, but that's a nice pattern that catches this sort of thing. And here it is in action. That's what it would actually run if I ran that. No hard code password. And that's what I told it to spit out. Yep. But notice it didn't catch this. It just says, because I would have said no hard code keys. It got there and then I told it to exit. I told it to like, all right, you're done. And there it's done. This wouldn't have failed on its own if I didn't put an exit because there's nothing to make it fail. You have to make it fail yourself. That's another point on building this yourself. And actually, there's a bunch of, but you also got to think about this because you're building it yourself. Like any solution, it starts with a simple idea. And the more you look into it, there's 1,000 edge cases and death by little cuts. And then the worst part is you got to go sell this to your team. And then you got to maintain it. One of my favorite quotes from the Drupal world was Jim Birch, who maintained a project that had about 10,000 users globally, an open source project. And he said, the best thing about this is that about 10,000 people love my work and know who I am. The downside is I have to maintain and support 10,000 users. And that's true of anything you build. I'm not dissuading you from doing it. You might want to go do this yourself. I don't know you. But the good news is that there's some really smart people that have already built all this, and this is where open source comes in. Let's go pull it off the shelf. I'm gonna talk about 3, but there are many more out there. Git leaks is the one you'll run into a lot. There's repos that are just completely full of detectors. These are just the 3 I'm going to talk about today to get you started. I have a personal preference on this list because, well, I work for one of these establishments, but I'm not here to sell you on it. I'm going to be very crystal clear on, on all of these. So AWS Labs Git Secrets. This is the first one I ever discovered in my personal studies back in like 2020 when I was first looking into this. So if you're 100% bought into AWS, there's this project or organization they have called AWS Labs. It's not officially AWS, but it's people that work inside of AWS that contribute open source that helps you with your AWS work. So this is completely tuned to AWS stuff. They actually install a Git hook at 3 different levels: the pre-commit, commit message, and prepare commit message, just to make sure that they catch it every time. I think it's a brilliant use of it. That triple check could save you in the specific right circumstance under the right conditions. We don't have time to get into the nitty gritty of what those conditions would be: authorship versus commit versus rebase versus author. Anyway, best part is it's free, completely open source. The examples I used earlier, if you're going to build it yourself, this is modified from their code. So that's where I got the idea to build that, is literally from AWS Labs. You can extend it all day. In fact, people have. There are people that have modified it to run for AWS, or I'm sorry, for Azure, for Google Cloud, for other weird platforms that I'm not going to name here. But yeah, you can just extend this out. It's just basically grep at a really cool level. But if you are going to extend it, you need to know regex. And I like regex, but I don't like writing regex, Then there's Trufflehog. I got nothing but good things to say about Trufflehog, which might be surprising if you're familiar with where I work. They were the first open source solution that was free to run that did this pretty dang well at first. They rely on the pre-commit hook framework, though. That's a whole other talk unto itself. It's really cool framework. Basically, there's a bunch of things you can do with pre-commit, a lot of security things, a lot of linting things, a lot of things you can jam into that hook. So there's a whole org, precommit.com, that is a framework written in Python that lets you, well, just pull things off the shelf and then just invoke them. It's this free tool I'm talking about right now, TruffleHog, is free and open source. They had built a business on top of it called Truffle Security. I have various different opinions about them, but I'm talking about TruffleHog, which I like. It does require that pre-commit framework, and if you're like, I don't want Python on my machine and I'll never want to enter pip hell, then stay away from this. You can run this GitHub action as well. You can technically with AWS get secrets, but that's not what it's for. This is like, we can hook it into the GitHub action, for instance, or not for instance, GitHub pull request process. So you can check for secrets before you hit the full PR and acceptance. High false positives, your mileage may vary on this. I've read a lot of reviews and it's all over the map. So again, for the right circumstance, this might be the right thing. And then there's Git Guardian's GG Shield. Now, this, fully admit, is open source as a tool, but it still requires an API call to the Git Guardian platform, where it authenticates and actually does the logic. So open source tool, but with a service reliant component. So just want to be crystal clear and upfront about that. Really easy to install, and you can install it at pre-commit, pre-push. Again, there's specific use cases when you're dealing with patches manually where that makes more sense. You can even do pre-receive hook in the right conditions. If you have an environment on your server side that can run executable code, so like a code space or a VM or a container in front of your, wherever you're running your GitHub actions on that local, like run it before the code actually makes it to the shared repo. If you're not familiar with pre-receive, that's a really cool part of the Git book. Go recommend, that's free. The Git book is on git-scm.com, completely free to read, and it's a little dated, but again, the concepts of Git don't ever really change that much. That's great. Anyway, GG Shield. Like I say, you do have to authenticate up to our software platform, our SaaS platform. But there's a free account. It has a limit of 10,000 calls a month. For most developers, you're never going to hit that. It's free for individuals, free for open source use, and free for teams under 25. Not a sales pitch, just that's the reality. So this is free software. You install it, like I said, multiple levels. We're actually over 400 kind of detectors now. I guess I haven't updated this slide in a few months. But we keep adding more specific detectors, and we look for various patterns. The one thing I will say, because we aren't just 100% open source library, we also have some pre and post validation checks that make the false positives go down quite a bit, because we're only reporting on things that we validated. But that's, again, not trying to sell you the product on this call. Go check it out for yourself. You can get it for free. So what does this look like in action? Well, I kind of already showed what this looked like in action. I go to make a commit, and hey, this failed because I had an API key there. Let's go see what it actually looks like, though. So clear. Look at my pre-commit over here. You see the only thing I have in there is secret scan commit, because I'm using GG Shield, obviously, for this demo. But if I run just a GG Shield secret scan and look through this entire repo, I will see, yes, there's a bunch of binary files and things it can't look into. And then it's like, hey, wait a minute, I found Wrong Secrets, if you're not familiar, is an OWASP project. It is specifically how to build things wrong related to secrets. It's a really cool project to teach you how to properly think about secrets and secret storage, but it's an OWASP project. Anyway, of course, it's full of secrets. That's the whole idea. But if I come in here and let's see, I modify that to be just a made up key, and I do a git add, and I do a git commit, minus M. Just say demo real quick because it's going to fail. Oh, wait a minute. I didn't make that commit because I got multiple secrets here. I have a key. I got, over there. And then this is specific to get to GG Shield. We also throw how to remediate. This is completely customizable. This is just some advice for you. I know there was a question around how do you enforce people to use these kind of tools, to use pre-commit scanning. And the answer to that is it's really hard. At the fundamental level, developers need to understand that first line. If they don't understand the don't hard code your secrets, you got a bigger problem on your hands and a much larger conversation. If they don't understand not committing secrets, again, that's an education piece. Use automation. If you're at the point where, hey, use this tool because it's going to save you a lot of time and they listen to you, then this is a really easy sell. This is literally, I showed you the entire thing. It takes 3 lines, one to install, one to authenticate, one to set up. 3 things to do GG Shield. Trufflehog's a little more complex. AWS is literally install the library, you're done. Or install the dependency and you're done. There's no real good, and that's one of the reasons I like githooks.com is there's a few things that point to solutions, but basically you can't pass around your Git folder itself. That's not how that works. That's not how Git works. Since hooks is a part of the Git folder, you can't just package it up, say, here, use this Git folder. That's wouldn't make sense. So there are solutions out there to let's make a library that you can then quickly install locally, but that's not that much different than here's a script to go install. And the adoption is going to depend on the developer. Now, there is such a thing as cloud development environments that have emerged recently. And those you can pre-configure with anything you really want. Looks like I got a question here. Is there a way to know if Git hooks have been run? In this particular case, yeah, there's a really easy one to know. Did a secret end up in your environment or in your shared repo? If it did, then they didn't run the Git hook. But no, unless you're tracking some kind of logging from that particular person's machine, it's not something you can easily track. But it's no different than like, how often did they save their file? You're never going to know that. Now, again, in cloud development environments, it's a different story. Those you can turn on audit logs. So if you're using code spaces or Git spaces, Git pod, I should say. Git pod is another popular one. Code anywhere. There's a lot of solutions out there. There's a whole nother talk about those that I give. There are options there where you can pre-configure the environments to already have hooks, to already have certain tools in place. And there you can do audits against them. But the only way you're going to know, did they run the Git hook that stops my secrets, is did the secrets show up or not? And that's kind of a false negative problem, ultimately. Anyway, I've been Dwayne. I work in Chicago, or I live in Chicago. I work all over the world. But go check out the Security Repo podcast if you thought this was interesting content, because I love having conversations. And hit me up on the internet about anything you ever want to talk about, and I'd be happy to. All right.
No, this was great, man.
Oh, I actually got one last question here. It was a direct message, so I won't repeat the whole question, but the problem with GG Shield is that a party will be receiving your company's secrets and are also not able to work in regulated environments. One, the air-gapped environment, we do sell standalone software that some very large companies are running out there. So that is not an issue. You're not sending the secret. You are running an indexed fingerprint of the secret. You can get more into go actually read our documentation. So understand the question, but we can talk about that offline or away from the recording, I guess. All right.
Cool. All right, man. Thanks a lot. This was a great session. And
All right.
brilliant, man. Very cool. Yeah, we'll put the recording online, and we'll send the link. And if you share the slides, would be great, and then we can put it there.
Yeah. I can share slides right now. They're Gmail slides, or not Gmail. Which column? Copy link. And this is with everybody. There you go. Those are the slides that I just used.
Cool. Brilliant. Brilliant, man. All right, good stuff. I'll then see you around.
All right. Thank you very much. Have a great one.
Bye.
Bye.